We have another example. So in this case, we're supposed to find the total resistance. Okay, so what I'm going to do first, I'm going to redraw this circuit. Maybe this is going to make this circuit looking a little bit simpler. So this is my voltage source. Okay, this is my voltage source. This is my resistor 2R. I have resistor over here 4R, and because these two resistors are in series, I'm going to say that this is my resistor 2R, because R plus R will give me 2R. And this is my voltage source, and I have current which goes through this resistor, and this current is equal 7 milliamps. Okay, and I know that the voltage source is having 21 volts across itself. So you have to realize that this is parallel circuit. Okay, in parallel circuit, the voltage across each resistor is the same like voltage source. So I can say that voltage source is equal to let's call this V1, voltage across this resistor, V2, and this is V3. Okay, so it means that voltage source is equal to voltage across resistor 1, voltage across resistor 2, and this is also equal to the voltage across resistor 3, and this is equal 21 volts. Okay, so it means that the voltage source is equal to voltage across each resistor. So we always look for the component which has, you know, the at least two pieces of information. So please notice that this resistor has also given the current, okay, which I mean the current is given which goes through this resistor, and we have also voltage. We're supposed to realize that voltage, right, V3, you can write that this is nothing else, just this is the product of the resistance and the current. So I can say that V3 is equal 2R, okay, this resistance, times the current which goes through this resistor, current which goes through this resistor. I will simply write this as 7 milliamps. Okay, I know that V3 is equal voltage source, so this is 21 volts, is equal 2R times 7 milliamps. I can say that 21 volts is equal to 2 times 7 milliamps is equal 14 milliamps. So I have R times 14 milliamps. I'm looking for the total resistance. I have to find the resistance. Okay, please notice that we are missing the R. Okay, so this R is going to be calculated from this equation. So what I'm going to do next, I have to find R from this equation. In order to find R from this equation, I'm supposed to divide both sides of this equation by 14 milliamps. So I'm going to divide this one by 14 milliamps and this one by 14 milliamps. This and this will cancel out. So if resistance is equal, of course, voltage over current, so I have 21 volts over 14 milliamps. This is equal 21 divided by 14 exponents 3 negative. This is equal 1.5 kilo ohms. So we found this that R is equal 1.5 kilo ohms. Okay, so this is the value of R. So right now I can say that my R1, okay, this is this resistor, R1 is equal to R. Okay, so 2 times 1.5K is going to give me 3 kilo ohms. Next, I'm supposed to find R2. R2 is equal 4 times R. So this is 4 times 1.5. This is equal 6 kilo ohms. And R3 is equal to R, and this is equal 2 times 1.5, of course, kilo ohms. Okay, so this is equal 3 kilo ohms. Next, I can simply find the total resistance. So R total is equal 1 over, open parenthesis, 1 over R1 plus 1 over R2 plus 1 over R3. So have R total is equal, always write the formula first, okay, always. So have open parenthesis 1 over R1, which is equal what? 3K plus 1 over 6K plus 1 over 3K. This is equal, R total is equal, and I have 1 divided by open parenthesis 1 divided by 3 exponent 3 plus 1 divided by 6 exponent 3 plus 1 divided by 3 exponent 3. Close parenthesis, this is equal 1.2 kilo ohms. We found the total resistance. So if we found the total resistance, we can redraw the circuit and we can replace simply the entire circuit which we have over here by very simple looking like this one. I have simply voltage source. It's my voltage source, and this is my total resistance. Okay, voltage source is equal 21 volts, and R total is equal 1.2 kilo ohms. Okay, so this is the equivalent circuit to the original one. So we can say at this moment that the problem is solved.